In this episode of the EU Energy Projects podcast, I am joined by Christos Christodoulou, coordinator of CABLEGNOSIS, a project developing next-generation power cable technologies to support Europe's clean energy transition. From advanced materials to AI-based diagnostics, CABLEGNOSIS is helping build the reliable, renewable-ready grid that Europe needs for 2030 and beyond. Christos, how does CABLEGNOSIS support the EU's broader clean energy transition goals, particularly the 55% emission reduction target for 2030?
Areti, we have to highlight here that we don't target directly to the reduction, to the 55% reduction of the emissions, but we contribute to this target by strengthening the backbone of the power systems. What is the backbone of the power systems? Is the transmission network. So, in this project, we develop new materials, new cable layouts and designs. We deal with recyclability issues in an effort to show more advanced cable systems that can facilitate the operators to share more renewable energy and to this direction to achieve the targets that European Union has for the energy transition. And we know as the renewable energy systems penetration increases, the need for efficient high voltage AC or DC cable links is also more demanding. So to this direction, our project will strengthen the transmission system of the European power systems.
Christos, with renewable generation expected to reach 50% of electricity production, what grid challenges is the project aiming to solve?
First of all, when we will reach that number, that share of renewable energy sources, we will definitely need more submarine and underground cable systems. However, there are several key challenges that we face now. What are these challenges? Thermal bottlenecks in insulation, aging caused by humidity or other contaminants, recyclability issues also. And of course, in the case of HVDC systems, we have more complex failure mechanisms compared with HVAC. So, in an effort to face these challenges, we propose some new cable layouts, a new design of cables, for example, smaller or larger cross-section. We introduce new polymer insulating materials in an effort to increase the thermal capability and, of course, the energy transfer capability. We deal also with recyclability issues because, after some decades, the cables reach their end of life and we have to do something with all the materials. And we introduce also some platforms and some tools based on AI techniques in order to perform predictive maintenance or a better and more efficient monitoring. So all this together can contribute to a more reliable, efficient cable system and, of course, to expand the lifetime of the cables.
And we're talking underwater, inland, everything.
Submarine
right?
and underground.
Submarine and
of course, cables are two choices, underground or submarine.
Yes, and we had recently in Greece an issue with a cable going the wrong way. There was a huge issue, if I remember correctly.
Yes,
right?
in general in Greece we are a special case because we have a lot of islands.
Exactly.
So there are a lot of needs for submarine cables. It's something that is very, challenging and demanding. And It always faces a lot of
Yeah,
problems.
but it's also good to to test. Let's say it's a good terrain to test,
Of
Greece.
course, of course.
Can you highlight the most significant technological innovations in advanced insulation, conductor design, or superconducting cables emerging from CABLEGNOSIS?
To summarize our innovation targets, we can say that we span in three pillars. First is new insulating materials. So we introduce polypropylene blends enhanced with nanofillers and thermoplastic polymers that offer a higher thermal conductivity and improved recyclability. The second pillar is innovative cable layouts, so new designs of cables. And the third pillar are the exploration of superconductors, especially for submarine cables. All the above are connected to platform in order to perform predictive maintenance, monitoring, health condition assessments, and also fault location. So we have an holistic approach of the cable systems, starting from the materials, the design, and also techniques to monitor, detect, and predict the health and the operation of the cable systems.
You mentioned already a couple of times recyclability. So I'm wondering how important is the development of environmentally friendly recyclable cable materials in meeting EU sustainability and circular economy regulations?
That's a good question. And what is the problem now? XLP is the most used plastic insulating material that we use in cables. When a cable reaches at the end of the life, we have, how to say, not a very good recyclability procedures, and we just recover materials that downgraded only for structural uses. So, to face these challenges, we introduce two major advances. First of all, we introduce new materials that are much more easy to recycle, and these materials can be used for low voltage electrical installations. It's not for high or for medium, but it's better than
I understand. Yeah.
existing situation. And second, we develop a new methodology to separate the insulating the materials, so to isolate only the insulating fraction from the cable. So we facilitate the recyclability, and of course, we have a step forward to the procedure, something that now it's not, very easy to do.
Where do you find the raw material? It's not an easy thing, especially with for cables, right?
Yes, it's not very
Is
easy.
it within Europe or
Within Europe.
Okay, that is already a very positive thing. What role do EU Commission policies play in accelerating investment and deployment of new cable infrastructure across member states?
Okay, European Union has its policies, its guidelines, especially for renewable integration and for cross-border interconnection, something that increase the demand for stronger HVAC and HVDC cable systems. I have to say and to highlight that we don't shape policies, but we provide technological solutions that help the operators to deploy new infrastructures in an efficient and safe way. So the policy frameworks creates the need, and our innovation help meet it with safer and more efficient cable technologies.
I want to discuss a little bit the issues faced. Are there any regulatory or permitting barriers that should be solved in order for cross-border cable interconnections and submarine interconnections to
Yeah.
be made, let's say, in a smooth way?
In submarine interconnections, there are a lot of regulatory and permitting issues. Again, with CABLEGNOSIS, we don't intervene in regulatory issues, but we provide the technological solutions and we reduce the technical uncertainty so the operators can go on with new technologies and to be sure that what they deploy, it will be technically safe. So by improving materials, by improving cable design, by offering tools to monitor the cable system, we reduce the uncertainties and we reduce all the risks that may be arise during the operation of a cable link.
If I'm not mistaken, the project is also using AI-based tools for pre-fault detection and aging analysis. How does this solutions improve reliability and, what is also a very important topic, reduce costs?
In our project, we implement some real-time PMU measurements and new sensing technologies in an effort to detect, and that is very important, to detect any case of anomalies before they develop into failures. And note here that a failure in a cable system, it's not something simple. It means a lot of efforts uh, to repair or to replace, and of course a lot of time because it's not something easy to repair or to replace. So we have the technologies and the AI tools in order to to detect the fault, to the type of the fault, the position of the fault, and also to make predictions about the lifetime of the cable and to have some estimation about the health of the cables. So this can lead to fewer outages and better maintenance planning, and of course increases the reliability and the cost-effective operation of the cable assets.
If I'm not mistaken, again, there are pilots in various European countries, in five: Italy, UK, Greece, Hungary, and Cyprus. What insights do you expect from the validation activities in these countries?
The purpose is not field deployment, but rigorous laboratory validation of all the technological components. So, in 5 countries, in 5 laboratories of high expertise, in high voltage engineering, in materials, in recyclability, we perform tests, laboratory tests, so we can ensure that these components and these new designs that we propose are ready and safe and reliable for an industrial uptake. And I repeat, we don't have field deployment, only laboratory validation.
Okay, understood. How will the feasibility studies, particularly for offshore wind parks in the Netherlands and Germany, shape future large-scale grid planning?
Yes, we use for a reference case and we perform a feasibility assessment of superconducting submarine cables using offshore wind interconnections in German and Dutch coasts. We don't design these interconnections themselves, but we provide a robust technical baseline that can inform future planning decisions and highlight where superconductors can offer benefits. So the study examines several issues like cooling options, environmental interactions, magnetic field consideration, thermal and electrical behavior of the cables, and of course recyclability issues.
Christo, as we're approaching the conclusion, let's say, of our conversation, I would like to ask you to look ahead and tell me how might CABLEGNOSIS innovations support major interconnection projects such as UK, Morocco, Cyprus, Israel, or the Aegean offshore links?
We have a dedicated deployment plan to examine how all the results of the project can be implemented in these interconnections in the future. So again, I will repeat, we don't implement these projects, of course, but we provide the technology, we provide solutions in order to facilitate these future connections. So I think that the contribution of the project will be very significant to materialize all these future connections.
Christos, thank you very much for your insights. For more insights, join the Enlit community.